Good morning. It's December 20th, and this is your daily brief in science. Here's everything you need to know. On December 19, 2024, Russian cosmonauts Alexei Ovchinin and Ivan Wagner ventured outside the International Space Station for a significant spacewalk, commencing at 10:10 Eastern Time. This event marked the third and final spacewalk for the ISS in 2024, highlighting the continuing efforts in space exploration. During the nearly 7-hour operation, the cosmonauts successfully installed an all-sky monitor, an X-ray spectrometer designed to observe celestial X-ray sources over a 3-year period. Alongside this installation, they replaced 4 electrical connector patch panels on the Zvezda service module and collected experiments intended for further analysis on Earth. Due to time constraints, the cosmonauts could not relocate an exterior control panel for the European robotic arm, but this task was deemed non-critical for current operations. Ovchinin humorously remarked as he disposed of older experiments, saying, "Here it goes, it is floating away," while pushing a bundle away from the ISS. Both cosmonauts have been aboard the ISS since September 11, 2024, as part of the Soyuz MS-26 mission, alongside NASA astronaut Don Petit. The 2024 spacewalks included a total of 5, with this being the second for Ovchinin and the first for Wagner. This year has seen a reduction in the number of spacewalks compared to previous years, primarily due to a suspension in June 2024 after a water leak incident in a NASA astronaut's spacesuit. The Russian Space Agency had also previously paused its spacewalk program for precautionary equipment checks. The spacewalk took place outside the Poisk module, which serves as a docking point for Soyuz cruise ships and cargo vehicles. During the spacewalk, cosmonaut Alexander Gorbanov operated the ISS's robotic arm from inside the station. The Large Hadron Collider, the world's largest particle accelerator, is making headlines again, this time for its unexpected connection to quantum computing. A groundbreaking study led by Professors Martin and Chris White has revealed that the LHC is not just a tool for particle physics, but also a valuable platform for exploring quantum theory. This research highlights the LHC's role in examining advanced computing paradigms, particularly through its production of a property known as magic when creating top quarks, the heaviest known fundamental particles. Magic measures the difficulty traditional computers face in calculating quantum systems, with higher levels indicating a greater need for quantum computing. Understanding and harnessing this magic is crucial for developing robust and controllable quantum states, which are necessary for advancing quantum computing technology. Professor Martin White emphasized that the LHC can observe complex patterns of quantum behavior, adding depth to our understanding of quantum entanglement. While previous ATLAS experiments have shown evidence of quantum entanglement, this new research illustrates more complex quantum behaviors at unprecedented energy levels. The study shifts the focus from traditional quantum research on entanglement to the suitability of particles for developing effective quantum computers. Published in the journal Physical Review D, these findings have significant implications for the future of quantum computing. The property of magic is essential for creating quantum computers that can outperform traditional methods. The potential applications of quantum computers are vast, impacting fields such as drug discovery and materials science, but they hinge on the ability to control quantum states, where magic plays a vital role. A groundbreaking study from Northwestern Medicine sheds light on the long mysterious mechanism of metformin, a widely used diabetes medication. Published in Science Advances on December 18, 2024, the research reveals that metformin lowers glucose levels by specifically blocking mitochondrial-complex 1. Led by Navdeep Chandel and Colleen Retchek, this study provides direct evidence of how metformin functions, addressing a significant gap in understanding its effectiveness. Chandel noted that this work clarifies the drug's action amidst various proposed mechanisms that have been debated for years. Additionally, the research underscores metformin's anti-cancer properties and its role in reducing inflammation, linking these effects to the inhibition of mitochondrial-complex 1. To explore how metformin targets this complex, the researchers engineered mice with a yeast enzyme that is resistant to the drug. The study received substantial support from multiple grants from the National Institutes of Health and other funding bodies, highlighting its importance in the field. Metformin, derived from the French lilac plant, has been a cornerstone in diabetes management for over 60 years, often prescribed as a first-line treatment for type 2 diabetes, frequently alongside medications like semaglutides. Today, metformin remains a critical component of treatment regimens for many patients around the world, reinforcing its significance in the management of diabetes and related health issues. NASA has made a significant move in lunar exploration by awarding Firefly Aerospace a $179 million contract under its Commercial Lunar Payload Services initiative. This initiative is a key component of the Artemis program, which aims to enhance our understanding of the Moon. Firefly's inaugural lunar mission, named Blue Ghost 1, is scheduled for mid-January 2025, targeting a landing site near Mons-la-Trille in the Mare Crisium region. The Blue Ghost 1 mission will carry 6 scientific experiments to the lunar surface. Following this, a second mission, Blue Ghost 2, is planned for 2026, which will deploy the European Space Agency's Lunar Pathfinder communications satellite on the Moon's far side. The 2028 mission will expand on these efforts, introducing advanced capabilities to deploy 6 scientific instruments weighing around 215 pounds to study the Moon's geology and environmental conditions. Among the key instruments for the 2028 mission are the Lunar Vulcan Imaging and Spectroscopy Explorer, a Heimdall camera system, a robotic arm for regolith sampling, and devices designed for low-frequency radio observations and neutron radiation measurements. A primary focus of these missions is to investigate the Gruithuisen domes, geological formations thought to have originated from silica-rich magma, which raises important questions about their geological history. Understanding the Gruithuisen domes is essential for gaining insights into ancient lunar lava flows and the Moon's geological evolution, especially since these features formed independently of Earth's geological processes. Joel Kearns from NASA's Science Mission Directorate highlighted the mission's potential to address critical scientific questions regarding the formation of the lunar surface. Firefly's CEO, Jason Kim, emphasized the benefits of having a production line for landers, enabling iterative improvements based on previous mission experiences. Future CLPS missions are also set to deliver NASA payloads to the Moon's near-side and south polar region, further propelling lunar exploration. The findings from these missions are expected to contribute to a burgeoning lunar economy and support future human exploration by revealing essential details about planetary processes and the Moon's evolution. Recent research has uncovered a link between human cytomegalovirus or HCMV and Alzheimer's disease, revealing its presence in the intestines and brain tissue of affected patients. This discovery suggests a potential pathway through which the virus may impact brain health. HCMV, a member of the herpes virus family, is usually contracted early in life and remains dormant in most individuals, but its role in neurodegeneration is now being scrutinized. The study emphasizes the significance of systemic factors in Alzheimer's, indicating that infections like HCMV could influence brain health and contribute to the disease's progression. It also highlights the connections between gut infections and neurodegenerative diseases, pointing to broader implications for brain health. Chronic intestinal HCMV infection may activate the brain's immune cells, known as microglia, leading to inflammation and potential neuronal damage. Previous research indicates that Alzheimer's patients show increased levels of CD83-positive microglia, which are linked to HCMV infection. These findings raise the possibility of developing antiviral drugs aimed at treating or preventing Alzheimer's in those with chronic HCMV infections. Experts are calling for further research to establish a direct causal relationship between HCMV and Alzheimer's, as well as to assess the implications for treatment and diagnosis. Dr. Eric Ryman, the senior author of the study published on December 19, 2024, in the journal Alzheimer's and Dementia, expressed optimism about the potential impact of these findings on future Alzheimer's research and treatment. The collaborative effort involved multiple institutions, including UMass Chan Medical School and Rush University Medical Center, underscoring the collective commitment to tackling this major health concern, which currently affects around 944,000 individuals in the UK and incurs costs of £34.7 billion annually. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.